So Sherry is out sick today, and I'm sure a lot of people who are here are probably here because Sherry invited you. So she really hates that she can't be here, and now I get to talk for her. And so I'm just going to talk a little bit about the Pediatric Technology Center and some of the things that we do. Let's see. I'm not as familiar with these slides because she made them for herself. So so what we want to do in the Pediatric Technology Center, which was established by Children's Healthcare of Atlanta, they funded us to begin because they really wanted to increase their research, and they felt like instead of building an infrastructure for themselves, why not use Georgia Tech? And so, of course, we're super excited to be a part of this and to be able to make these technologies. What we really want to do is try to make sure that kids are as well taken care of as possible. And so, again, I don't know what's on these slides, but essentially, I'm going to turn to the next slide. I don't know this slide. Here we go. But essentially what we want to do is, and in my job every day as Chief Engineer of Pediatric Technologies, is I will talk to clinicians, understand what their pain points are, and I will get back together with people on campus that I think can solve the problem. And it can be really any area on campus, so from policy to data analytics to robotic surgery and all the things that you just saw that Scott Hollister does that are so amazing and great. So what we did with these are we have different mechanisms to, sorry, I really don't know these slides. We have different mechanisms to fund research. We started out with seed grants, which is like a little bit of funding that you might get to see if an idea works, and then move it forward from there through maybe an NIH grant to follow on. We did something called Quick Wins, and Quick Wins was a very unique program. It had a rolling deadline, and the idea was if there's something that we thought we could get in the hands of clinicians in 18 months or less to use, that would be the type of thing that we funded through the Quick Wins program. And that's really unique because there's really no other thing that focuses so much on that applied research and that applied technology. We also had child impact grants, which are larger, a little bit longer term study. You might think of virus-like particle research to treat cancer or diagnose cancer. There's a lot of different things that we do in that area, and that's just one example. And if you're interested in what I just said, the virus-like particles to treat cancer, we had a tech talk just yesterday, and it will be up on our website in a week. It's an interview with MG Finn, and he talks about all the research he's doing in that area. We do only patient-driven problems. And so instead of where you think in academia typically, a researcher will study one thing like maybe virus-like particles, and the goal is to figure out what can we learn from them and how can we use them. But what we do is we only take problems from the clinic. So a physician has to have a need, and then we put the team together with them. And of course, I pick the people who are working on things that I think are appropriate for that. But this is really different for research. Not a lot of people work this way with the problem first. Oh, and you can see some of the different topics that we do. So, anything. We work all over Children's Healthcare of Atlanta, which has 5 different locations around the city, and one of them is the Marcus Autism Center. So we do a lot with the people over there as well. Now, these are the things that I know more about. So. This first project is really interesting. We have a program called the Petite Scholar Program here at Georgia Tech. And it's run out of another IRI, just like iPad, except it's the Institute for Bioengineering and Bioscience. What it is a program where a student will work with a faculty member during the course of a calendar year, and that student will be in charge of their own project. And what Children's Healthcare of Atlanta did, because they really care about raising the next generation of researchers as well, is they started funding some of these scholars. And so these students could come from anywhere on campus. It didn't have to be in bioengineering or bioscience. This one happens to be. And this is a great story because the student that built this app is a student with anemia himself. And so he wanted to work on a technology that would work for him. And he thought, is there a non-invasive way to test my anemia levels other than taking blood like you have to do? And so he was really smart and figured out a way to take an image of his fingernails and determine what his anemia levels are. One of the things that he had to overcome was the true technology challenge of lighting. So if anybody knows cell phone applications where they have to take pictures of something and somebody has to analyze it, lighting is always one of the main problems, and he figured that out, and so we're so proud of him. He's made this great app. The other thing is he now was a student in the Pediatric Scholar Program, and now he's a mentor, and so there's another student that he's advising this year to continue his research. So it's a really great example of once you get started and once you can find somebody with that passion to do something, you can raise the next generation, you can help the next group and help them have that passion too. So I love that project. And, okay, so along the same lines, in the same lab, one of the biggest problems for people with anemia are women who have problems with anemia. That makes pregnancy very dangerous. And most of these women have sickle cell disease, the ones that we've been working with, obviously a larger problem here in the Southeast. But so there's all sorts of things, though, that you can imagine that we can do, whether it's through technologies like this or other detection technologies that somebody might be working on. But this lab has about 3 different projects that they do in anemia. All right, IV infiltration, one of my favorites. And so I've been working on this project as well. So what can happen when you get an IV is when they stick the needle in the vein, maybe they miss, maybe they poke through the vein, or maybe the vein bursts after you do it. So what we wanted to do is figure out a way to detect when IV infiltration happens. And we want to do this because it causes really horrible damage to the child. And so you can imagine in infants who their veins are tiny and they're fragile, this happens more often. And you can imagine that if you have a severe issue or reaction to this, then that's a condition that's going to stay with you the rest of your life. And so it's really important to find these early and take care of them. Let's see. And one of the reasons we do this is because, like I said, that the medicines are so caustic that they eat away at the skin and the muscle and the tendons and the nerves, and so you literally create permanent damage and a disability for these kids depending on where it is and how bad it got. So nurses told us if we could detect it in under 30 minutes, then we could really save a lot of these kids, and it's much easier to fix at a cost of about still $40,000. But if you let it go longer than that, that's when it can create these worse things, and it's millions of dollars over the life of the child. So what we wanted to do is say, okay, we can do this with sensor technology, with flexible electronics, and we want to do something that's easy for the nurse, put maybe some electronics and sensors in the dressing that goes around the IV site, which you can see in that picture. And what we want to do then is we want to try to detect if we can tell when the liquid seeps into the skin as opposed to being in the vein. And so we are using a couple of different means right now. One is a temperature sensor, because the liquid is usually a different temperature than the person. And then the other one is bioimpedance. So we've found that the bioimpedance changes when the liquid infiltrates the skin. We've done this in animals, and we think we're going to be able to do a detection in like under 5 minutes. So we're really excited about that because we're really catching it early for the clinicians. And I think that is going to be great. This was a problem that was brought up to me originally probably 5 or 6 times by different people saying this is a really big problem. And so that's one of the reasons that we focused on this. And I think that's the last slide. Oh, nope. Up next. Or some of the things that we've done, actually, is what it should say. So we've launched Pediatric Home Lab, and Brad Fain, I saw him in here earlier. There you are. Brad Fain is the one who runs Pediatric Home Lab and also the Adult Home Lab version that we have. It's all about being able to test out technologies in the home with these patients who are going to be using them, with examples of patients who are going to be using them then in the real world once the technology reaches the market. We also launched our Tech Talk series, which I mentioned earlier. So once every 3 months, we give a 30-minute discussion. It's a webcast, and then we put it up on our website. And so the most recent one was about using viruses to diagnose and help defend against cancer and beat cancer. Let's see. IV infiltration data collection, so the project I just talked about, we're getting ready literally in just a few weeks to start collecting data on humans, and we're going to go through the summer with that, so we hope that we get the results that we think we will. I think that'll be really exciting. We have set up a pediatric research endowment. So what we're doing here is Children's Healthcare of Atlanta gave $8.5 million to Georgia Tech to help build the building and brand the building that I actually sit in. And in addition to that, though, there was going to be a match for $8.5 million to actually conduct research in pediatrics with Children's Healthcare Atlanta. So we're really excited about that to bring some real great opportunities and funding opportunities to everybody. And then we wanted to do a little plug at the end here. So I'm also the president of the International Children's Advisory Network. It is an advocacy group that gives a voice to kids in their health care. So we have our kids talk to and tell their stories to the FDA or NIH. We want them to help people understand about their condition. We work with any type of condition, so it's not just cancer or sickle cell disease or whatever it might be. We take kids of all types, so most of our kids have rare diseases, and so it's good to have them come together for each other because they maybe don't know anyone else with their same disease, right? And then Sherry Ferrugia is the vice president of the International Society for Pediatric Innovation. It's another group we work regularly with. And the idea there is that I think about 100 different children's hospitals around the country are members of ISPI. And so it's bringing those clinicians together to look and see how we can progress technology in the future. And so we each consider ourselves, even though they started separately, that we're the patient arm and they are the provider arm. And so it makes a really great partnership when these groups come together and work together. And I think that's it. Yes, thank you.